Hello, guys. My name is Desmond, and I welcome you to my lesson for today, where we'll be looking at mathematics. So, ladies and gentlemen, as always, please do allow me to say it is very much important that I say it is very, very much important because Bosisi, what I'm about to say is massively, hey, massively important, ladies and gentlemen, that I say a day without learning something new is a day wasted. By so saying, please, Larissa, please do make sure that by the end of each and every lesson that I conduct, you learn something new. Very, very much important, ladies and gentlemen, over there. Okay, just a quick recap. This is all that we did in yesterday's lesson. For now, I'm not going to be touching anything on that, but towards the end of our lesson, we might need to quickly have a look at that. But for now, I want us to quickly focus on exponential laws or the laws of exponents, and also have a look at exponential definitions. Once we are done with this chapter, the next one will be focusing on SATs, and I'm pretty much sure that from there we'll be able to tackle exam type of questions. So I did send a compilation of previous exam papers in the group. You can easily access that. So, good people, before I start with the business of the day, just to confirm that all is in order, everyone is able to hear me when I speak, can you just, maybe 3 of you, unmute your mic and say something? You can just say hi or mention your name, then mute your mic. In that way, I hope you guys are able to hear me.
Yeah. Hi.
Okay, it seems like all is in order. It's fine. Good people, the laws of exponents. It's what we'll be looking at. So it's actually more like a revision. I'm pretty much sure that most of you guys are aware of these laws, but just to accommodate everyone, we will just quickly run through those laws. There's a law which says if you are having a to the power, let's use maybe letter M for Maria. When you multiply the whole of that by a, maybe let's use a letter N for Noah. So there's a law which says when you multiply that by that, this is the same as what I'm about to explain. But before I do that, let me quickly make you guys aware that when it comes to the laws of exponents, you just need to be able to identify what we call the base and also what we call the power or the exponent. I'll just give you guys a quick example. If we have 2 to the exponent of x, this is what we call the base, and this is what we call the power or the exponent. Similarly, if you have y to the exponent 7, this is what we call the base, and this is what we call the exponent or the power. Only if you can remember those, you won't struggle to understand everything that I'm going to explain. Okay, so now, what is the base there? The base is A. What are the exponents or the powers? We have the power of letter M and the power of letter N. So what the law says is that if you have the same basis, listen very carefully. If you have the same bases, you can just represent them by one base and you add or you sum the exponents or the powers, meaning you are going to have M plus N. I hope That was pretty much easy and straightforward for everyone to understand. In terms of numbers, you can maybe have 3 to the exponent, let's say 3 multiplied by a 3 to the exponent 4. So what it means is that this is the same as 3 because you have the same base being 3, the same base being 3. As long as it's the same numbers or the same letters, you can just represent it as one base. What do you do to the exponent? As we have done there, you take the exponent of that, you add it with the exponent of that, meaning this is the same as 3 to the exponent 7. I'm telling you, if you can say 3 to the exponent 3 times 3 to the exponent 4, punch it on a calculator, and also punch 3 to the exponent 7, it is going to give you the same answer. That's how you know that you have correctly applied the law. So I'm about to move on to the second law. This was law number N. Just a quick indication. Did you guys understand? Just a few of you to respond to this question. Was it clear to everyone?
Yes, we did understand.
Okay, 100%. So I'm going to remove all of that. I'm just not sure if you guys are writing as I explain, but do not worry that much. In case if you are not able to write and listen at the same
Sorry,
time, this lesson
sorry,
is being recorded.
sorry.
Yebo, Zain Zain.
Yes, yes, yes. I just want to check, man. If,
Yeah.
like, say, for example, 3 times 3, the base is 3 most, ne?
Yes, the base is 3.
And then you just add those powers.
Yes, you
Just
just
add
add
the
the
powers.
powers. If it's 3 times 3, maybe to the exponent 2, let's say it's that. So can you
Oh,
see here you have a
yes,
power which is an invisible 1. It's not
1, yes,
written as
yes.
1, but you know this. Yes, that means this is going to be 3, 1
Over.
plus 2, which is 3 to the exponent 3. So you
Make 5.
punch that on a calculator and that it will give you the same answer.
Okay,
Makes
that's fine.
sense. Okay, so now let's move on to law number 2. Guys, I'm asking you, please, 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 please do make sure that you pay full attention to all that I'm going to explain, because for you to solve for exam type of question papers, everything that I'm teaching you now is what I'm going to be applying to those math problems. Sometimes you might get amazed or just be wondering when you see someone solving a math problem and you wonder, how did they know this is where they start? How did they know they were supposed to do that step after that step? How did they know they start with this step and whatever? If we can pay full attention to everything that I'm going to explain, I'm telling you guys, you will fully understand why mathematics is easy. So law number 2, we are having, maybe let's use the same base of A. Remember, it doesn't matter whether the base is A, B, C, D, or any letter up to Z. As long as it is the same letter or the same number in the position of the base, then you apply the law. So here we are having A to the exponent m, or to the power m. Now it is no longer a multiplication, but it is a division, meaning we are having over A to the exponent n. Okay, so now uthini umthetho? Umthetho uthi when you are given something similar to that, remember, it could be a letter or a number. Doesn't really matter that much. So the law says, can you see? You are having that as the numerator and that as the denominator. Let me quickly try to explain something very much important, Bantu Bagiti. When you have something over something, just know that at the top you have what we call a numerator, and at the bottom you have denominator, meaning 2 over 4. This is numerator, this is denominator. So you need to be aware that this is your division sign which separates the numerator and the denominator. Very, very much important. So I'm trying to make sure that I mention everything, because as we go deeper, I don't want you guys to be hearing me saying a word and it sounds like it's one of those bombastic words. Just make sure that you write your notes and you listen very carefully. Okay, so we are having a base being A. Also there we have a base being A, meaning I can write that as A, but because there's a division sign, then it's going to be that power of the A at the top. In this case, you don't add, but you minus the power of that at the bottom. Maybe let me quickly try to do an example using the numbers. Let's say you have 2 to the exponent 8 over 2 to the exponent 4. Here comes the question. Are the bases the same? Yes, they are the same. So now, are you multiplying the bases? No. You have the whole of that divided by the whole of that, meaning you can just have 2 to the exponent 8 minus 4. Remember, guys, I noticed someone just joined and they've got their mics unmuted. Honorable member, remember to always have your mics muted. There's a button where you can click which says mute. And again, Bantu Bakiti, just in case if you did not know, make sure that on your screen you don't have this piece which is showing everywhere I'm writing and there's a list of learners, because you might be missing some information on my screen. Make sure to click on that screen where I'm writing so that you maximize the space. So in that way, you'll be able to see the edges of this whiteboard. So just make sure that you have full view of everything that I'm writing. Okay, so now, can you guys see? It's easy because you have the same base. You have 8 minus that, which is what? Which is 2 to the exponent 4. If you punch that exactly as it is on your calculator and punch that, you are going to get the same answer. I'm not sure. Did that make sense to everyone before I move on to law 3?
Yes, we understand.
I think Busisiwe said
It's clear, very clear.
Yes, we
she
understand.
understands. Okay, 100%. I just remembered that sometimes there's a delay in message. You might find that what I'm saying now will be delivered to you after a few seconds. Vuyo, yebo.
Let's say it
Is
was
it
2 to the power
Vuyo?
of 8. Yeah. Let's say it was 2 to the power of 8 over 2 negative 4. Yeah.
Okay, a very good question. So I will actually follow the same process view. The law says, are the bases the same? And answer to that question is a yes, meaning you are having base 2. What does the law say? It says you must subtract the exponents, meaning I'm going to have positive 8. Listen very carefully. Positive 8 minus negative 4. Can you see? This is me applying the law. But a genius, thanks very much for this question, Voiso. A genius won't show you all of these steps. They already know that it's going to be 2 to the exponent 8 plus 4. How do they know? Already they knew that a negative times a negative, it gives them a positive. So someone who's genius, they'll just say this is 2 to the exponent 12 and they leave it there. You'll just see them looking southwards and smiling, and you wonder, kahle kahle kwenze njani? Wenzeni lo muntu lo? Vuyiso, uyayithola lento le ngichazayo lapha? Uyayithola?
I understand. Thank you.
Okay. There will be some more of tricky questions that we'll be dealing with, but trust me, I'm going to make them very, very much easy for you guys to understand. Okay, law number 3. Law number 3 says if you are having, let's stick to letter A, to the exponent m for Maria, close to the exponent n for Noah. So in this case, Bantu Bagiti, the law says if you are now having the base, which is just one base, inside the brackets, you are having a power there. This is actually the same as the powers multiplying each other, meaning you are having the same base to the exponent m multiplying n. I hope that also it is straightforward. Maybe let me try to explain using some numbers. Let's say you have 3 to the exponent 3 inside the brackets to the power of that. This is the same as, can you see, that multiplies that power, meaning you are having 3 to the exponent 3 multiplied by 4. What is that times that? I think it's 12, meaning you are having 3 to the exponent 12. I'm telling you guys, if you punch that exactly as it is, you might find that it's exactly the same as that. That's how you apply that law. Makes sense, Bantu Bagit?
Yes, sir.
Okay, good people, just make sure that you have your mics muted, especially after joining the lesson. Okay, so now let's quickly move on to law number 4. Law number 4, this is what we are now having. Let's say we have letter A for Abraham, maybe, let me see, we've got Busisiu. Let's maybe use letter B and then we close. Maybe we still stick to Maria. The law, Bantu Bagit, it says, remember guys, if you remember very well, I did explain that a term has got a sign, a number, a letter, and a power. Meaning, if you have A, this A has got a lot of things hidden over there. You have an invisible positive and invisible 1, then you have visible A, and you also have an invisible positive 1. Meaning, that A, it's actually A to the power of invisible 1 multiplying by B to the power of invisible 1. So now I'm going to explain the law. Remember guys, just like law number 3, that exponent, as long as you are having something inside the brackets to the power of whatever, that whatever multiplies the power of that, and it also multiplies the power of that. Meaning we are having A with its invisible positive 1, it multiplies that M. Multiplied by B, that invisible 1 multiplied by M. That is why a genius will just say an answer to that, it is just A to the exponent M times B to the exponent M. And you wonder, which law did he apply? How did they apply the law? Easy as it looks. A to the exponent 1 times that, B to the exponent 1 times. Maybe let's use the numbers. And I'm going to make it a little bit more interesting now. Let's say we are having 3x to the exponent 4. Let's say y to the exponent 3, and maybe let's close and say to the power of 2. It looks a bit intimidating, but I'm telling you guys, you will fully understand how to apply the law. I'm also going to explain to you how you normally make mistakes. This is what you do. Can you see? This is the law. It says whatever whatever that is inside, you have to multiply its power by 2. The question is, this 3, what do we do to that 3? Does it have a power? Good people, it has a power of invisible 1, meaning an answer to that question is going to be 3 to the exponent 1 multiplied by that 2. So it multiplies that, multiplies that, times x to the exponent 4 multiplied by that same 2, times y to the exponent 3 multiplied by 2. You end up having 3 squared x. What is that? I think that is 8. You have y. What is that? That is 6. Also, you know very well that 3 to the exponent 2, it's 9. So you're having 9 x to the exponent 8, y to the exponent 6. So guys, sometimes during my lessons, I do make mistakes with numbers because I hardly use a calculator. So when I say 4 times 2 is 8, for some reason, if I say it's a million, just make sure that you double check on your side, you punch on a calculator, and you correct me if I made a mistake. So we all do mistakes, but luckily in mathematics, mistakes are correctable. I think before I forget, I would like to just mention something to you guys. The reason why I like master classes is because I learn a lot from you guys. I've learned a lot from my previous learners in the previous years. How do I learn from you guys? With you asking me questions, the manner in which you ask me questions, I'm able to notice that this is where you get confused. So on my next lessons, I improve when I teach you guys based on your engagement with my lessons. And sometimes we learn some new tricks from other learners in different schools. So just make sure that you never miss this type of lessons, because you're not only going to be learning from me as the tutor, but you guys will be learning from each other. So you will notice that as we continue with our lessons. Here comes a question. Did that make sense to everyone before I move on to the next law?
Yes, it makes sense.
Sir.
Makes sense, nay? Okay, so law number 5. Okay, let's try to explore this law. Let's say you are having A over B close to the exponent M. Here is a law of T. Remember, guys, don't be confused and say you are having that over that, therefore it's something minus something. In this case, be careful. The bases are not the same Bantubagiti. The first thing to check is if the bases are the same. If they are not, think of something differently. So in this case, they say that exponent Bantubagit, it multiplies the exponent of that and also the exponent of that. What does it mean? It means you are going to have a to the exponent invisible 1 multiplied by n over b to the exponent invisible 1 multiplied by n, which is the same as a to the exponent m over b to the exponent m. It ends there. You cannot somehow work out that and that. Why not? Because the bases are not the same. Maybe let me use a practical example. Let's say for some reason examiner gives us that over that to the exponent that. Can you guys see? This is what we are having as the law, but look at what examiner gives you. And they expect you to get it correctly. Now, how are you going to apply that law? This is what you ask yourself. What is the base, or what are the bases there? The base is 4 having a power of invariable 1. Here, the base is x having a power of 2. Are the bases the same? No. Okay, if they're not the same, it means you just multiply that by that by that. Meaning, you are going to have 4 to the exponent invisible 1 times 3 over x to the exponent 2 multiplied by 3, which is, what is 4 to the exponent 3? Let's see. 4 times 4 is 16 times 4. It's 8. This one, I think, needs a calculator. 4 to the exponent 3 is 64. So that means you are having 64 over what is 2 times 3? That is 6. That one is easy. So that means this is how you simplify that, applying that law. I'm just not sure if I confused you guys with this one. I'm very much worried that you guys are confused that side. Zain, are you sure?
If the bases were the same.
Okay, if the bases were
I'm
the
correct.
same,
I'm
it's a
with you.
different story. You apply that other law. But remember, guys, remember, for now, I'm just showing you how the laws work. When it comes to if whatever was whatever, and if whatever was whatever, that will follow to solve exam type of questions. But maybe let me remove that, just so that you guys understand how to differentiate between those laws, because they can be confusing. Who wants to give me that example? Someone is saying if the bases are the same. Can you maybe try to give an example that I will explain? Who was it? Was it you, Voiso, or was it Zain? Who was it? I'm not sure
It was me,
who
sir.
was that
Maybe
on.
it was 2 to the exponent m over 2 to the exponent m.
Maybe a different
Exponent
letter,
n.
ne?
Oh, exponent n, yes, sir.
Then we close, ne?
Yes, yes.
Let's make it interesting and say to the exponent p. What do you think?
Yes, it's correct, sir. It's okay.
Okay. Remember, guys, this is a question that you ask yourself. Are the bases the same inside? Yes, the bases are the same. What does the law say if you have the same basis? It says you write the same base, and because you have that divided by that, you're going to say m minus. I'm not sure if it makes sense, guys. Then, now that you are done with, so it's more like this is a combo, a combination of the laws. So you have applied that first law of having numerator over denominator having the same basis. You've applied that law. Now you need to apply that law that says when you have something inside the brackets and power, you multiply the power by the power, so power to power. Meaning you have the base having the power of what? Of m minus n, and that power multiplied by that power. Maybe let's call this low power to Bantubaki. I think it's going to make it very much easy. If you hear me saying power to power, don't say away. I'm not talking about Amanda, but I'm talking about power to power. Voice, happiness. Maybe a voice understood it, but did everyone understand?
Yes,
I'm
sir.
still with you.
Yes, sir.
Because I am well aware that these laws are confusing, and I'm going to spend as much time as possible to make sure that you fully understand. So this is what happens, guys. I'm going to quickly explain to you what happens at your schools and the reason why we have to start a bit early. So what happens at school is that you are given a pace setter which says at this period you should have been done with this and that and that and that. So what happens is that your teacher teaches you all these laws today. Tomorrow you move on to the next thing, next thing, next thing, next thing, next thing, and so on. So what happens is, as things get complicated, you worry much about trying to understand the complicated question and not bother that much to understand the basics. What I mean by what I'm saying, Bantu Bagit, is that do not, never allow me to move to the next thing until you understand the basics. I'm expecting all of you guys to fully understand so that when we get to complicated questions, when I say power to power, you then remember exactly what I'm talking about. Don't hear me saying power to power and someone saying, are we thinking I'm talking about Amanda? Guys, before I move on to the next part of our lesson, did that make sense to everyone? I think it did. But please allow me to quickly do this. Let's say we are having 2 to the exponent x ways. Not even 2. Maybe let me say 8. And we also have 8 to the exponent that. Then here, let's say we have a 3. So this is how you're going to work out this one. You are not just going to straight away say this, that by that. You can still do that. Maybe let me do it in 2 ways. You can apply that law that you know, which says if bases are the same, you subtract the exponents, meaning you have a to the exponent x minus y. But remember, you still have that, meaning this is going to multiply your power. So you are having 8 to the exponent 3, it's multiplying that. You can further simplify this and say this is the same as that times that times that, meaning you have 8 to the exponent 3x minus 3y. Another way in which you can do it, if you don't want to start with that one of working out the same basis inside the brackets, you can straight away say that times that times that. So that means you're having 8 to the exponent 3x over 8 to the exponent 3y. Because you said 3 times x, it's equals to 3x, 3 times y, it's equals to 3y. And this is the same as, because the bases are the same, is the same as 8, 3x minus 3y. So can you see, takes you back to that. Remember, guys, when you multiply a letter and a number, for example, if you have a p multiplying, let's say 4, never write it as 4p. You write it as 4p. Why? It's because a number multiplies a number. Where is the number on that p? It is that invisible 1. So it's like you are having 1 multiplying 4p. That is why you have 4p. That is why if it's 2, it is 2 times 4 and it becomes 8p. And it is not 2p4. I hope that makes some sense. Okay, guys, before I move on to the next part of our lesson, did you guys understand all that I've explained regarding law number 5?
Yes, we did. Yes, sir.
No, understand the one that had a 64, the one that had 64 on the answer.
You quickly want me to run through that one?
Yes, sir, please.
Okay, so here comes the question. Are the bases the same there? No. You have the base being 4 to the exponent 1 over base being x to the exponent 2 in that case. Okay, so since the bases are not the same, it means I cannot work out the numerator and the denominator. I will therefore have to say that times that and that times that, meaning you are having 4 to the exponent. What is 1 times 3? It is 3 over x. What is 2 times 3? What is it? 2 times 3, I think it's what is it? It's 12. Yes. So can you see, if you punch 4 to the exponent 3, it gives you 64. And you have x. If you have 2 multiplying 6, it gives what? 12. I'm not sure, Luvuyo, if iyazwakala nanku. How do I say it in Zulu?
Yes,
Iyazwakala ngoku. Uyayithola ne?
sir, thank you.
Okay. So,
Wait,
maybe
sorry.
you.
Let's say it was like addition. So, for example, like 2 to the power of 4 plus, I don't know, 2 to the power of 3, close brackets, and then another power of 2 outside.
Okay, what to write there? 4 plus?
3.
Okay, plus 3.
And then close brackets to the power of 2.
Okay. This is what you would do. You can just add that and what is that? Say 4 plus that is 7. That outside. Then you can just say that times that. Meaning you have 2. What is power to? Hey, power to power. What is that by that? It's 14. Meaning you can just punch that and it gives you your final answer. Make sense, honorable member? Remember to unmute your mic in case if you want to respond. So it does happen that sometimes you respond, but you get to unmute your mic. So it's going to be the game of the year where you keep on muting. But wait, guys, are you not being lost there? Zazaza, Tanisa Muli, Mavis, Kuli, all right, Gamo, Rosalind.
Yes, sir.
Okay.
No,
Now, who's speaking is Vuiso.
yeah, sorry, I meant like 2 to the power of 4 plus 2 to the power of 3, close the brackets, and then to the power of 2 again.
Oh, so maybe this is what Vuisa is saying, times ne 2 to the power of 2.
Addition, like, yeah, like this, but addition, not the times.
Or addition in between, something similar to that.
Yes.
Okay. So this one, Vuisa, remember, you may be given. Let me firstly try to think of something, Vuisa, because sometimes you as a learner, you might give a problem which is an error, but this one is not an error. You might give something which is not an error, of which you cannot apply any of those laws. But what I'm going to do now, so I'll just make an assumption that this is as it is and explain how to work it out. But what you were actually asking, it's something a bit more complicated than that, even though I'm not pretty much sure of what to think of, but I'll find a question that relates to what you were asking. Easily, this one view, so you'll notice how easy it is, and it's not really what you wanted to ask. That is because that to the exponent that, what is that? Is it not 16? I think it's 16. Plus, what is that to that? Is it not 4? I think it's 4. You see, then what is 16 plus 4? That is 20 to the power of that 2. Can you see? What is the power of 20? It's an invisible one. Can you guys see? To power. Meaning you have 20 to the exponent 2. Then if you punch 20 to the exponent 2, it gives you a number of which, if you still punch all of that, it gives you the same thing. So what you were asking about Vuiswa, it has to be a valid question from one of the past question papers where you have a plus sign in between. And I'm going to show you exactly how to work it out. Does it make sense?
Yes, I understand.
Okay. So for now, guys, we are completely done with the exponential laws. So I'm about to move on to the definitions. This is what I'm going to do, Pantubakiti. As soon as we are done, I'm going to share with you guys the notes that I was using to prepare for this lesson. I'm going to share a summarized version of what I've just explained. So everything that I was writing there, I will share a screenshot in the group for you guys to be able to catch up on your own. So in case if you couldn't write anything, don't worry that much. So the definitions are coming from number 1 up until number 11. So I just need you guys to pay full attention because sometimes you are given this type of problems and you do not know how to interpret them. So I'm going to quickly run through those, and then from there we look at a few exam type of questions just to interpret them. As soon as we're done, I'm telling you guys, I'm pretty much sure that starting from tomorrow or the day after tomorrow, we'll then start working out exam type of questions, and that includes the recent exam paper. Okay, number Ian, the definition says if you have a to the power of 0, listen very carefully, a to the power of 0 is equal to 1. How do I know? They say anything to the power of 0 is equals to 1. That means a dog to the power of 0 is equals to 1. That means 2 to the power of 0 is equals to 1. That means a house to the power of 0 is equals to 1. That's what I mean by anything, Pantubakiti. As long as it is to the power of 0, it is equals to 1. Meaning, on your calculator, try to punch any number. It could be that, and say to the exponent 0. It is going to give you 1. I'm pretty much sure that that one, it was straightforward. So I'm now going to move on to number 2. This is what it says. If you are having 1, listen very carefully, to the exponent of a, this is the same as 1. And sometimes they extend to say that's if, for example, a is the element of real number. Meaning, if you have 1 to the exponent of 2, on your calculator, it's going to give you 1. If you have 1 to the exponent x, this is the same as 1, even though you might not be able to punch x on a calculator. But if you have 1 to the exponent 90, this is the same as 1. If you have 1 to the exponent 30, this is the same as 1. I hope that makes sense. So I'm only going to take a little pause on the ones which are a bit complicated. And also, I know someone is wondering, how do I notice that in an equation? What if you are given an equation in this manner? Do not worry that much, Bantubagiti. We are going to do some questions related to everything that I'm explaining now. When I say power to power, you will remember I'm referring to this lesson. So very, very much important that if you joined this lesson a bit late, make sure to catch up, to start from yesterday's lesson. Watch this one from the start until the end. Okay, here we are having x to the exponent negative 1. I want you guys to notice something. X to the exponent negative 1. This negative, it is the one that allows us to say this is the same as 1 to the exponent x. To 1 over x to the exponent positive n. So it's more like mathematically, we always try to have a positive power. Someone might be wondering, where is that 1 coming from? Because I don't see 1 there. Remember, guys, you always have an invisible 1 from yesterday's lesson. That is why if you have 2 to the exponent x, 2x to the exponent negative p, and they say this thing, it is the same as that because it has a positive exponent. So we just write it there as 2 over, this is the one that you take to the bottom. Why that? Because it has a negative power. Then you write it at the bottom as a positive power. That is why when you have x multiplying y to the exponent negative 1, this one, it is written as this one because it has a positive power. We can just leave it at the top as x to the power invisible 1 over this one. A genius will just write it as 1 as y to the exponent positive 1, because they know very well that the moment you have a letter to the power 1, it is the same as just a letter. I'm sure you guys have been wondering all along that why, when you are given something similar to that, you write it in that manner. It is for that reason, Bantibakit. Maybe if you have x over p to the exponent negative, let's say 2. Can you see? Now you have that over that. So to write that power as a positive, that is why you say you have x with its power which is positive. You bring that to the top, but as positive 2. This is the same as that. That is the same as that. I hope that makes sense. I'm not sure if there's
I
someone
didn't
who's got
understand.
a question.
Hi,
Who's
can I ask?
speaking? Yebo.
That means when you take what you call when you move. But now
So you can
that
also
you
give me
just
an example.
okay, it's gonna be x. Or p plus 4 to the power of positive 4.
Okay.
So now you need to rewrite it the other way around. So it's gonna be x equals p to the power of negative 4.
A very good question, honorable member. This one, you don't need to rewrite it. Why? Because already the pieces have positive signs. You only rewrite it if you have a negative power. We are told a manj.
Only if only if it was -4, then we take it up to be negative +4.
Yes, only if it was negative, then you always try to rewrite it such that you have positive exponents.
Oh, okay, I understand now. Thank you.
Yes. I think someone said something, or someone said they do not understand. By the way, this is a definition number 4 that we are explaining. Maybe let me quickly do it and say, if you are having a times x to the exponent negative n, can you see you have a negative power and asifuni a negative power kushukuthi kumele siyi-change siyenze i-positive power manje so yenza kanjani. Okay, can you see there you've got your first base. Does it have a positive power? Yes, a positive invisible one, so we just leave it as it is. It's only this one with a negative power that we will write or rewrite as x to the exponent positive n. Then when it's like this, there's nothing more that needs to be done. It already has a positive exponent. But what if it was x a? No, let me try to be practical and say maybe x over y to the exponent negative p. Can you see? We are having something that we don't want to be having, which is what? A negative exponent. Meaning, this one is a positive exponent, you just leave it as it is. Then you rewrite this one as a positive exponent being positive p. Then it ends there. I'm not sure. Does it make sense now?
Okay, so I understand this one. But then is there a way that the first number can be on a negative? Let's say it's a to the power of -4, and then x to the power of -7, let's say.
Oh, a very, very good. So b to the exponent negative 2 times, let's say b to the exponent 4. This is what you are saying now.
Yes.
Thank you very much, honorable member. I was going to miss that one. Okay, unmute your mic and let's speak. I'm going to help you to answer this question. You tell me, do we have something which is in the format that we do not want?
Yes, both of the exponents are negative.
Yes, both of them have got negative, meaning we have to write something over something. Do you agree?
Yes.
But now, what are we going to write there?
I think we must start with the first thingy, a minus.
Okay. This is something that you need to be aware of. There is an invisible one there. Yes. Meaning you are going to have 1 over 8 the exponent positive 2 and a positive 4. Can you guys see?
So, but then the B one doesn't have a 1. Up there, you say it's gonna be
Yes,
1.
you mean that B?
Yes.
Yes.
Shouldn't
Even if you
be there
still
1.
want, even if you still want that one, really matter. It could be 1 times 1, which is equals to what? It's 1 over the same thing. So let's say, for example, you have 2a to the exponent negative 7 times maybe 3b to the exponent negative 4. So that means you're going to have something over something, which is that being 2 times that being 3 over, take those at the bottom is positive, and then that positive. Then you work out that times that, which is 6 over that. Does it make sense?
Okay, so we multiply the bases and then we divide them by the exponents.
Let me listen to her very carefully. So it's more like these are the coefficients, but not the bases. So it's more like you multiply the coefficients, and then from there, these ones you rewrite them at the bottom to have the positive powers.
Okay, cool. I understand. Thank you so much.
Okay. So now let's quickly move on to another one, which is a bit interesting. Let's say we are having x negative that. Okay, easy. Can you guys see? Someone is being confused by now having the brackets and whatever. Do not worry that much. Just know that there's always that invisible angle there. So, suppose we have that in negative, then we have our angle over the whole of that as it is, but with a positive exponent. So that means this exponent, it is for the whole of that being the base, and this is the coefficient, meaning you can still have, let's say, -2. Yeah, let me make it a bit interesting. Let's say x and y close to the exponent -2. Yeah, let's see. Good people, this is a negative, but it is not in the position of the power. Therefore, you write it at the top as -2. Don't think of trying to somehow also taking it to the bottom and write it. Can you see it becomes a bit funny? So now that means whole of that, you will just write it as it is with a positive exponent. Who was it? Busisiwe. Thanks very much for asking that, because what happens is that in class we teach you what I taught you, and if you've got a question and you don't ask that question, they're going to bring it like this in exam and you'll be confused. So that is why it is very much important that during my lessons, in case there's a question that I need you to respond to, I'm not really expecting a correct answer, but Kuli and Hamisa will tell you that it helps me a lot when you guys give me the wrong answers, because it adds up to the mistakes that I've made during my high school time. In that way, if we can make sure that we do as many mistakes as possible during our lessons, it is guaranteed that when you get confused in exam, you will remember that these are the types of mistakes associated with these types of problems, and you will then make sure that you follow the right procedure. So this is an opportunity for you guys to make mistakes. Yebo.
Okay, so by the
Who's speaking?
Okay, so if x was replaced by a number, for instance, let me say 3, then inside the bracket it was going to be like 3y. Were you going to take that 3 under the thingy, the division thing? So what was going to happen?
Okay. Sorry, honorable member, can you quickly repeat what you just said? What did you say there?
Okay, so if in the brackets you had a number, if it was 3y, what was going to happen with the 3? Was it also going to go down?
Oh yes, if it was wait, 3 there, ne? If it was 3y there, ne? Yes. We also take it down. Let me maybe do this. Can you see this thing? I would like to also encourage you to catch up on my yesterday's lesson. Let's break it down. This part is the coefficient. This part is the base. That part, it is the power. Meaning, it does not matter whatever the base that you are having, you also take it down, because we are only focusing on the exponent being either positive or negative. So if it is negative, it forces you to take the whole base down. I'm not sure if you understand that, honorable member. Meaning, if we had rows, we also take that rows in the position of the denominator. Okay, so I hope everyone understands what I've just explained on
Thank you so
that
much.
one. Okay, so now maybe quickly this one, you will also understand this one, because now we are just doing a reverse of what I've already explained. Can you see? We have that as a negative exponent, which is not something. So that means we are going to have that 1 multiplying x to the exponent n, and it ends up just being that. Can you see? It's a reverse of what I've already explained. If you have 2 p to the exponent 1, that means this is the same as 2, then you rewrite it as p to the exponent positive that, which is the same as 2 p. If we have negative 7 over, let's say, 3xy to the exponent negative 2, then you rewrite it as negative 7 as it is, multiplying 3xy to the exponent of positive 2. Does it make sense, Bantu Bagit?
I don't understand.
Yes, sir.
I hate. I don't understand. Okay, let's say you have 2 over p to the exponent negative 1. Honorable member who said they don't understand, can you maybe unmute your mic so that we quickly redo it on behalf of all honorable members?
It's gonna be 2. We write 2 as it is, and then it's gonna be p to the power of positive 1 is just 1.
Yes, which is just a
And then
2p.
2
So
p.
yes. So, honorable member, remember, when you have, let's say, x to the exponent 2 over y to the exponent negative 4, ask yourself this question: do I have a negative power there? If an answer to that question is yes, then you need to rewrite it as a positive power. You see, your negative power is at the bottom, meaning you need to take it to the top as a positive power. So this is the same as you write it as it is because it already has a positive power. Multiplied by y to the power of, then you rewrite it as a positive power. Does it make sense now, honorable member?
Yes, sir, it makes sense. But what if the x had a negative exponent of 2?
A very good question. A very, very good question, honorable member. A very, very good question. Thanks very much for that. Okay, let's say we're having that. Bossis, here comes a question. You tell me, are we having something which is unwanted there?
Yes, we do. It's the
What is it?
minus y to the power of minus 3. And then also x to the power of minus 2, 1, yeah.
So that means you rewrite this at the bottom and you rewrite that at the top. Meaning you are going to rewrite y to the exponent positive 3 at the top. Then you rewrite this at the bottom as x to the exponent 2. Shokti lana si change ama position. I'm not sure if you guys are tolling this thing. Honorable member, are you tolling it now?
Yes, sir, I understand. Thank you.
100%. Okay. Quickly. Yebo.
Hello. Yes, I have a question. If it was negative 7 over open brackets 3xy close bracket negative 2.
That.
Yes.
Okay. What has a negative power there?
It's the 3xy.
Yes. Then you rewrite it in that position with a positive power. Can you see this one? It has a positive power of 1, so you just write it as -7. Then you bring this one to the top. It becomes what is it, 3x that and that. I'm not sure if it makes sense, honorable member.
Yes.
Yeah, so it doesn't end there, but for now I'll leave it there. So when I say it's a combo, that means you are given that, then you're going to apply that other law which says you must do that by that, that by that, but you remember power to power. So that means you're having 3 to the power 2 times x to the power 2 times y to the power of 2. Then what is that? You still have that, but what is that? This is 9, meaning you have 9 that. Can you see? Then what is that times that? Then you say 7 times that, you get negative value x squared y squared. Then that's how you simplify, and they give you 4 marks. But for now, I'm not teaching you how to simplify, but you just apply the laws and explain how the laws works. And then as soon as we go deeper, I'm going to then train on how to apply those laws. Makes sense?
Yes, thank you.
Okay. Okay. I need to quickly wrap up to allow next lesson for mathematical literacy. Okay, so let's see. Let's say, for example, Busisiwa, this one is going to be very much interesting. What if we are having that? I will explain and keep it simple. Remember, the law says you must say that by that, and then you have that by that. So that means you're going to have a to the exponent negative m over b to the exponent negative m. So we have unwanted negative powers there. So you will rewrite this at the bottom as a positive power, and you will rewrite that at the top as a positive power. Meaning you have b to the exponent positive m, you have a to the exponent of positive m. I'm not sure if that makes sense, but T.
Makes sense.
Hey. Okay, 100%. I'm very much happy that you guys did confirm that it makes sense. Maybe this is how your friend who's genius can explain it to you. Otherwise, your teacher, they can just say, when you have that, this is the same as b over a to the exponent positive m. Maybe let me just do this so that it's clear. I want to make you aware that sometimes people try to play the genius by taking shortcuts. But it might be danger if someone does that, because they'll confuse you. Someone can say the whole of that, it is the same as b over a close positive m. What are the difference there? Can you see what I've changed there?
The exponent has become positive.
Is it the only change? Larry, so.
No, sir, and the numbers have exchanged.
Yes. So, how did that happen? Remember, this times that, it becomes a to the exponent negative m, and then that times that, it becomes b to the exponent negative m. Nay, the second step, you remember, you have unwanted things, that, meaning you have b to the exponent positive m, and then a to the exponent positive m. But can you see, both of these have got the same power. So that is why it's more like they factorized the power and took it out as that, which is that. So just know that in case if your teacher says this is the same as that, just remember the process to get to that. I'm not sure. Does it make sense to everyone? Bantu bakithi.
Yes, sir.
Okay, in that case, I'm going to quickly go to that PDF that I sent in the group. I'm not sure if it's going to be blurry today. If you remember, in this same group we are attending, there's what is it? Combo. We are on paper 1. We are on solve for X, and this is what I sent in the group. Maybe let's try to have a look at this. Do you guys see? Can you guys see that question?
Yes, sir.
Okay. There on the next page, let me check if we also have a similar question. Can you see? Now we have that one on this year. Let's see on the next year what examiner asked. It seems like it is not there, but otherwise it's fine. Okay, maybe let me quickly run you through these two and then we'll be done for today. I'll just copy it down. So this is what you're given. M to the plus 4 minus 6 times 3 to the exponent m plus 1. Vuyiswa. Vuyiswa. Yes, obusisiwe. This is what I meant when I was saying I suspected you wanted to ask about this type of a question, which has a minus and is allocated 4 marks. Maybe let me quickly explain to you that when you have this type of a problem that has a minus in between, it simply means you will have to take out something as a common factor. That's all that it means. If you have a sign of a plus or a minus, it doesn't matter whether it's at the top or at the bottom. It means you will take out something as a common factor. How do you take out something as a common factor? Firstly, this is what you do. You need to separate the powers. How do you separate them? You remember that law. You just work it out in reverse. You remember that law that says 3 to the exponent that times same base to the exponent 4. Same basis, you add exponents, it takes you back to that. So it's more like the laws are explained in this direction, but examiner wants you to do a reverse of what they taught you in class. The only way in which you learn, that's if you watch us, your tutors solving for these problems, and that's how you learn all the tricks. Minus here, you are having 6, which is just a number. You are having 3 to the exponent m multiplied by 3 to the exponent invisible 1, all over 7 times 3 to the exponent m multiplied by 3 to the exponent 2. Remember, guys, I'm a bit fast because I need to allow for the next lesson. So I'm going to redo all these questions, but for now, I just want to quickly show you guys how I was going to do it in exam. This is what happens. Can you now see I've got a common factor over 3 to the exponent that. A common factor is the same thing that appears on both sides of the minus or the plus sign, which is 3 to the exponent m. Then what remains is that, because you take out this, you write it there. Because it is the same, you just write 1. Then whatever remains, you write it inside, which is 3 to the exponent that minus, can you see you're having that times that, which is 6 multiplied by 3 over, you have 7 multiplied by 3 to the exponent m multiplied by that times that. So can we now see that these are the same, they cancel each other out. Then you just simplify that, you punch that, you minus it with that times that over that multiplied by that, you get your final answer. That's how you score yourself 4 marks. But for now, I will leave it there. I know I was very, very quick, but did you guys have an idea of what I was trying to explain there, even though you did not fully understand? But did you get my point?
Yes, we did. But sir, can we please start with it tomorrow? Can you please start with this problem tomorrow so that we can get the time to ask questions and explain properly, because we are just very fast.
Yes. So, what I wanted to do for now, it was just to give you an exposure of what to expect in exam. But one thing for sure, tomorrow we will do more of this type of questions so that you guys are exposed to all the exam type of questions. So, do not worry that much, honorable member. We will revisit that question. Here's another one from that same PDF that I sent in the group. Here's the question. Just have a look to make sure that I copied it correctly. Because, Busisiwa, it happens that sometimes if I copy something and I don't do this for you guys to verify, I might copy it incorrectly, especially with trigonometry. I copied incorrectly and we tried to work it out and we spent 2 years. And on the third year, we realized that it was actually 14 degrees and not 41 degrees. So I think I've copied it correct. Okay, so now, hey, okay, I'll just quickly mute this one. Okay, let's see. Here, what I would do, I already noticed that I've got a problem where I need to apply the laws of exponents. Remember to explain to you, how do you see that you need to apply the laws of exponents? In short, if you have a letter in the position of the power, that's when you know you need to apply the laws of exponents. For example, if you have 2 to the exponent y, you must apply the laws of exponents. Why? Because the letter, it is in the power. And if you have y to the exponent 2, you can't apply the law of exponent. You don't need, you can, but you don't need to. Why? Because the power, it is not the letter, but it is the number. I hope you guys, those of you who attended yesterday's lesson, you realize that maths is actually a game of numbers and letters. Letters from A up to Z, numbers 0 up to 9. And you can see here is letter N. So what I'm going to do is to try and have the basis as their smallest number. 2 cannot be written as, for example, 1 to the power of something. 2 is just 2. Then you leave it as 2 to the exponent n plus that multiplied by. Then you have, can you see, 4? It can be written as 2 to the exponent 2. Can you guys see? I've written 4 in a different format. So over also 8 can be written as 2 to the exponent 3. So I haven't really changed that original problem. I've just rewritten it in different form. Why did I have to do that? It's so that I've got the same basis. Can you see? But before you can apply any law, just have a look at that. Here, you don't need to do anything. You can just write it as 2 exponent that. Listen very carefully. Power to power. Can you see what I meant by power to power? Something will be, someone will be thinking of saying a weight, thinking that I'm saying amanda. I'm saying power to power, meaning powers multiplying the power. So I'm having 2 exponent that by that, it is 2n. What is 2 times that? It is 2. Say power to power, meaning that by that. So you're having that, what is it? 3n, and that by that, it's negative 3. Then what do you do in this case? You remember a law which says when the bases are the same, you add the exponents. So that means you are now going to have just only 1, 2, which is something that you write on your next step, and just add the exponents, meaning that is going to add up with that, and you end up having, let's say, 2 to the exponent. What is that? It's going to be 3n. And then what is 2 plus 2? It is going to be 4 over 2 to the exponent 3n minus 3. Sure. It doesn't end there, Pantubakiti. Can you see? You still have the same basis. And you remember that law which says when you have the same basis, you subtract the exponents, meaning you're going to have 2 to the exponent, the whole of that being that. Then you minus that, you minus that. So you minus the whole of that. Then you work it out. Hey, guys, that's how it gets interesting in mathematics. I'm telling you, if you missed my yesterday's lesson, if you missed today's lesson, you can imagine how difficult it's going to be tomorrow when we solve for exam type of questions. It's going to be a disaster. That's why I'm saying never, 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 never miss my lessons. I'm telling you guys, by the end of this month, you will be having an idea of exactly what is mathematics. Good people, do you allow me to leave it at this point and say we will continue tomorrow? Are you guys
Yes.
happy that side?
So is the final answer 2?
Possibly,
Yeah.
because let's see, that minus that, and then is 3n minus 3n is 0. Then when you work out that, I'm just not sure if it's going to be positive 3. Just be careful of that. You might find that you are having 4 plus 3 and not 4 minus 3. That's another mistake that you guys make. So it's going to be 2 to the exponent 3n minus 3 minus into the whole of that, which is 3n minus, no, here is 4. I made a mistake, minus 3. So can you see, honorable member, it is 2 to the exponent 3n minus 4. You say this times that and that times that. Then you end up having
Plus 4.
negative 3n, but it's plus, what is it? Plus 3
4.
there. Can you see? Did I make a mistake somewhere?
Yes.
Where did
Plus
I?
4.
Oh, yes. Let's see. Yes, it's plus 4. Thanks very much, Honor. Okay, so now can you see? Is 3n minus 3 and they cancel each other out. Oh, yes, then we are having 2 to the exponent 4 plus 7. Can you guys see? Then this is 2 to the what is that? I think this is 11. Then you have that. But we'll see all of that tomorrow and confirm if it is 2 or it is 2 to the exponent that. Does it make sense, Bantuagi?
Yes, sir.
No, it doesn't. It's not making any making sense. This is
It's
not
not make sure.
making.
Hmm? Okay, let's make an assumption that it's not make sure, and then we'll revisit it tomorrow. But for now, I think I'll just end it there. Otherwise, averagely, would you guys say
No, it's going
so
that.
far so good?
Wait. Yes, sir.
Supposed to be 2 to the power 7, sir.
Okay, it's fine. Let me remove it and say we'll revisit it tomorrow.
And
So, guys,
listen.
I do thank you very much for joining. My name is Desmond, and I'm out.
What if